Okay, good morning, class. Our topic for this morning is illustrating systems of linear equations into variables. So the objective of our lesson is to illustrate systems of linear equation into variables. So, according to the definition of linear equation in two variables, it is an equation that can be written in the form ax plus by is equals to c, where a, b, and c are real numbers. A is not equal to 0 and b is not equal to 0. So, when we say system of linear equation, it is the combination of two or more linear equations. So, that the reason why it is called again as linear equations, because it is referring, or it is the combination of two or more linear equations. So, what if the equation is it's just one? Oh, it is alone. So this is called as linear equation. So when the equation is just one, so it is called a linear equation. But if it is when it is a combination of two or more linear equation, then it is called as system of linear equations. So system of linear equations, uh, again, I already discussed that the system is just a combination of two. So the system of our linear equation is ax sub 1 plus by sub 1 is equals to z sub 1. That is for the equation 1. And for the equation 2 is ax sub 2 plus by sub 2 is equals to c sub 2. So we have two forms of linear equation. So the first one is the standard form. So it was written in 2x plus y is equals to 6. So the equation or the linear equation is being written in that form. So the other form is slope-intercept form, where the value of the given variables was already given because it was being arranged. So it was written in y is equals to negative 2x plus 6, and for the equation 2 is y is equals to negative 4x plus 8. Okay, so let's proceed. So, a solution to a system of linear equation in two variables consists of an ordered pair that satisfy both equation. So, the solution of linear, it satisfies both equations. So when it satisfies both equation, then you got a correct answer. Okay, so there are three types of graphs of system of linear equation. So the first one is intersecting line. So from the word itself, intersect, it means it it intersects at one point. So they nag-cross sila sa isang point. So intersecting lines is syempre the lines that intersect. So it is called as intersecting line because it intersects. So they meet at one point. So has one solution. So since they meet at the one point, so it means they have only one solution for the two equations. So they are consistent and independent. So that is the characteristic of intersecting lines. Okay, so let's proceed to parallel lines. So I'm sorry for, I know. Let's go back to coinciding lines. So coinciding lines is the line that coincide. So the solutions are in the same line. So it has infinite many solutions. Since they are in the same line, it means all of the points are solution. So as you can see, the points or the dot or the ordered pairs are follows in one direction only. Okay, so therefore it is consistent and dependent. That is the kind of their system. Okay, so for the third one is parallel lines. So when we say parallel lines are two lines that do not intersect. So opposites siya doon sa intersecting lines. So it has no solution. So why? Because there is no intersection between the two lines. So that's why no solution siya. And this is called, the kind of the system is inconsistent. So, okay, for the next slide. So how are we going to identify the kind of graph through the given linear equations without putting putting the dot, or without plotting a graph, or without using a graph to identify the kind of graphs? Okay, so I will teach you the easiest way to identify using the equation only without using it, plotting it to the graph. Okay, so we have the given examples here. So the systems of linear equations. So for number 1, 7x minus, so there, as you can see, or as you can observe, in every equation that we use, there is a break or breeze. So the reason why there is a breeze in every two equations, for the equation 1 and equation 2, there are two breezes that covers them. That signifies that the two linear equations are together, so that you will not hindi ka malilito. Okay, so the first example is 7x minus y is equals to 4 and 6x plus y is equals to 5. So the given problem is in the standard form. So what we need to do? So we need to transform it into a slope-intercept form so that we can identify the slope and the y-intercept. Okay, so we're going to transform the first equation into the slope-intercept form. So the result is negative y is equals to negative 7x plus 4. So once we are going to transform the number into the right or left, the sign will change from positive to negative or from negative to positive. So since the given slope-intercept form is negative, so we're going to multiply the linear equation in both sides with negative so that we can have a positive linear equation. So the result is y is equals to 7x minus 4. And then for the second equation, y is equals to negative 6x plus 5. So how are we going to identify that the graph is intersecting line, coinciding lines, and parallel lines? Okay, so as you can see, the slope is unequal because the first one is 7 and the second one is negative 6, so they are not equal. So we are going to put in our slope as unequal. And then for the y, it is not equal also. But the reason why I put some equal or unequal, because there are instances that the y-intercept is equal and the slope is unequal, and that is also considered as intersecting line, because one of your bases at this part is that you're going to base to the slope to identify that the line is intersecting lines, because the slope is unequal, whether the y-intercept is equal or unequal. So you're going to base on the slope. Okay. So the next example is 4x plus y is equals to 6 and 4x plus y is equals to x. So we have similar linear equation. So we're going to transform again into a slope-intercept form. So we have y is equals to negative 4x plus 6, and y for the equation 2 is y is equals to negative 4x plus 6. So let's going to identify their slopes and y-intercepts. So for the slope, since the first equation has negative 4 and the second one is negative 4, therefore their slope is equal. So for the y-intercept, the first equation is 6 and the second equation is 6. So again, their y-intercept is equal. So once their slope and y-intercept is equal, therefore it is a coinciding line. So once we say coinciding lines, it has infinitely many solutions because or since they are in the same line, and it means all of the points are solutions. So they are consistent and dependent. So you can identify the kind of graph through observing to its slope and y-intercept. Okay, for the third example is 5x plus y is equals to 15 and 5x plus y is equals to 10. So our given linear equations are in a form of standard form. So again, we're going to transform it to slope intercept form. So y for the first equation, we'll transform it and the result is y is equals to negative 5x plus 15, and y for the second equation, y is equals to negative 5x plus 10. So at this juncture, we're going to identify the relationship of equation 1 and equation 2. So since the equation 1 has negative 5 and equation 2 is negative 5, so it means they have an equal slope. So for the y-intercept, for the first equation, 15 and the second is 10, so they are unequal for its y-intercept. So the parallel line, so when the slope is equal and the y-intercept is unequal, so therefore the lines is parallel lines and it has no solution because there is no intersection between the two lines and it is inconsistent. So once again, okay, let's review. So to identify the kind of systems of linear equation without using a graph, so we must observe to its slope and y-intercept. So if the lines is intersecting line, then its slope is unequal. And then the y-intercept, it can be equal or unequal. So among the three graphs, if we're going to see the slope, only the intersecting lines has an unequal slope. And then for the second one, when we can identify that the line is coinciding line, so when the slope is equal and the y-intercept is equal, so it has infinitely many solutions and consistent and dependent. So for parallel lines, when we can say that the given linear equation is a parallel lines, so if we're going to see its slope, the slope is equal but the y-intercept is unequal, so that they are in the opposite situations of intersecting lines with the intersecting lines. So again, once it is intersecting lines, the slope is unequal and the y-intercept is equal or unequal. And for coinciding lines, the slope is equal, the y-intercept is equal. And for the parallel lines, the slope is equal and the y-intercept is unequal. So, do not be, huwag tayong malito sa intersecting lines kasi let's observe it with its slope, di ba? Tapos yung parallelized lines naman, stable talaga yung y-intercept niya na unequal. So when we say coinciding lines, both slope and y-intercept is equal. So this is the end of our discussion, and I hope that every one of you have some learnings with our discussions about about illustrating the systems of linear equations into variables. So if you have any questions, clarifications, so you can contact me or chat me on my messenger so that I can give you some informations that you do not understand during on our discussion. So once again, good morning and be safe everyone, and God bless.